So I'm doing this video as a help resource for the quiz the kids are taking Friday. I'm guessing a lot of you will probably not see this in time, but if for some reason they don't do well, there will be retakes available and you can use it for the retakes to help them make sure they're prepared for that. Hopefully they do well tomorrow. I will say I sent out an email to everyone that based on practice, um, the kids are not grasping the material at this point. One of those reasons is a lot of them were choosing to socialize in class and to not practice. So that has been an issue, an ongoing issue in some classes. Whenever I finish the lesson and I allow them to work with each other, they tend to move away from working on the math and just talking. And this is certainly not true of all students. In some classes, though, it is true of most students. So that's a whole nother subject. In this video, though, I just want to try to go over what I passed out that they were working on in class, and they should have brought that home to work on at home. There are also additional problems in the online book, or if they brought their physical book home, which not many of them do. But if you want to go to the online book, if you feel like they still need more practice after doing this worksheet, I'll show you at the end of this video how to get to that, or it's also on the YouTube page that I sent out. I don't know if it worked or not, but hopefully you guys are finding it. But I'll send another message with how you get to all of that stuff. So first of all, in their books, at the end of every lesson, there's this key concept page. So right here, this is like a summary of the whole lesson. So this particular lesson, actually the last two lessons were on exponents. So we took some notes, like there's notes they should have. We did a worksheet at the very beginning of it. They should have that worksheet. We only did the top of the worksheet. It was called home, I think it was somewhere up in the top right. It said homework 11 exponent rules, and then it also said perfect squares and square roots. But we didn't do anything with the perfect squares and square roots. We just did the top section. The top, I think it was like 8 problems. So they should have that completely filled out. And I'm not going to repeat that. It's actually old 5th and 6th grade math, not 7th grade math that they were supposed to already know, but we reviewed it. So again, this is what we're learning in 7th grade, these rules. So they have to do with the way exponents work. I am not going to do a full lesson here. You guys can always just Google on or go to YouTube and just say exponent lesson 7th grade. Or in this case, you could type in product of powers law, again, in YouTube. And then you can get more detail on that if the kids are really struggling or if you're struggling to help them. I don't tell the kids this, but I will tell you guys this, and if you want to show the kids, it doesn't really matter. There are apps that you can use, math apps, that will solve it for you and show you all the steps. Now, obviously, the kids have to do it themselves on the quiz, but if you're really struggling to figure things out, there's nothing wrong with doing that, and then just making sure the kids can duplicate that on their own before tomorrow, or before whatever retake they do. But anyway, this is a summary. These are the rules I'm going to be using. We used these in class. They did not. I'm going to say they didn't do a very good job of trying to use them. They tend to just say they don't know how to do it and ask questions instead of using these notes in these pages or their notes in these pages. So they've really got to work on using their resources, using their notes, using these pages in the book. That's the only way they're going to learn it. Me just telling them how to do something is not going to stick. They're going to forget that the next day. They got to figure it out on their own if we want them to retain it. So this is the first page of the worksheet. I'm going to try. I just got this software installed, so I'm doing this a different way than I have in the past, but let's see if it works. Oh, and it's not going to work. Well, shoot. Why does that not work? Shoot, shoot, shoot. What am I not doing right that is not letting me do that? Alright, so here's what I'm going to do. I'm just going to have to flip back and forth. There's normally a way to show both pages at once. I don't understand why that's not working. I'll play around with that another time, though. I'm not going to worry about it right now. So again, these are the rules that I'm going to refer back to. Really, for this homework, that I'm about to show you, these rules are not going to apply. This was old stuff we did, not today's work. They need to know how to do all of these things up, but you may have to go back to the book problems for them to practice these. And again, I'll show you. I probably won't show you the actual problems, but I'll show you the assignments that I gave them at the end of this video. All right, so anyway, in this particular, there's nothing like these first two problems on the test. All they had to do on this was just pretty much plug into a calculator this number here, and then they would divide by 7 to get what this means. 7 to the 4th means 7 times 7 times 7 times 7 times 7. Or they could just say 7 to the 3rd. So again, the exponent is 3. They should know this. Means 7 times 7 times 7. So they would just do that in a calculator. There's actually a calculator button that would allow them to just type in the number 7, hit the correct button, and then hit 3, and that gives them the answer. There's nothing like that on the quiz. That's too easy. We're not just plugging numbers into a calculator. Not that simple, at least. We're not just plugging numbers into a calculator. They have to know how to do it in a specific way. These two problems right here, where the exponents are 0, that was just a rule. We learned that if the exponent is 0, so right here, if the exponent is 0, it doesn't matter. A is just stands for any number. Doesn't matter what number it is. It's just a variable. Could be any number. Could be a million, could be negative a million, could be 1/2, could be negative 1/2. Any number raised to the 0 power is 1. So, and again, they should know these, but like I said, they weren't all necessarily working, and there were some that were struggling. We'll do it in red. So the answer to that is just 1. The answer to that is just 1. The next problem is a rule as well. Oh, what they should also have written in their pages, or on that one page, next to this, they should have written in there example 1. Again, I made them write that if they were present, so I'm just going to write EX. They should have written example 1, though. And then over here, they should have written example 2. Because these two rules, if the kids were struggling to figure it out with the variables are the letters. So if they were struggling to understand what these letters meant, I said, well, just go to the example that we had already gone over these examples. Go to the example. It looks exactly like the problems on the worksheet. But again, a lot of them are struggling to focus and follow instructions. Again, I've tried moving seats around, but in some classes, they just all know each other. So I'm not, again, this is why I keep sending messages home, especially to some classes. They've really got to learn to focus when they're around their friends. So if they go to example 1, this page here, this page right here, was page 48, I believe. So, I don't know what that was. So this little key concept thing, no. This key concept thing was on page 48. I believe on page 46, you will see example 1, and it looks exactly like the problems we're about to do. On page 47, you will see example 2. It looks exactly like the other two problems we're going to do. So I'm not going to try to pull it up. I'm trying to keep this short, but it's already longer than I kind of wanted it to be. So this problem right here is just like example 2. The rule is a little different because that you need to understand, or they need to understand, this problem can be rewritten. That's, let's zoom in. Just this one problem. There we go. So this problem, that's an 8 and that's a 4, can be rewritten as 11 to the 8th power divided by 11 to the 4th power. And again, we went over all of this in class. And we, like I said, we practiced that rules page for a while, and still we were struggling by the end of class. So now if I rewrite it like that, it looks exactly like the rule. the rule is, not that one. This is the rule. Same base, though the a is called a base. It even tells you that right here. Different exponents, and it looks like a fraction. Same base, 11, different exponents. So I'm not going to keep flipping back and forth. You can go back to it if you want to rewind the video. The rule says and there's another version I showed them. I'll show you one time. If I take the base and just write it. Oh, I'm doing the wrong thing. Take the base, rewrite it. Then what I do to solve, this is how they need to write their answer, by the way, on the quiz for most of the problems. This is called exponential form. Again, the first worksheet we did had all of this on it. I can take the two exponents and say top exponent, subtract bottom exponent, and that is what the answer would be. It would actually wind up being 11 to the 4th power. Again, that's what the rule just tells them. It's very straightforward. They've done this for a week and a half now, exponents. And this rule we probably spent 3 or 4 days on. I mean, these rules I'm doing. Now, I'm going to show you one thing. And again, I know a lot of you probably haven't been in math class for a very long time. But I'm going to show you another way I showed them how to do this. So over here in this area, 11 to the 8th power, so this might help you on some other problems as well. That just means 11 times itself 8 times. Oh boy, this is going to be, here I'm going to have to zoom in probably to even write this as many times as I need to. So, let's try to get it on the screen. There we go. So here's the problem. Oh no, I want to see the whole. There we go. 11 to the 8th divided by 11 to the 4th. Well, 11 to the 8th means 11 times itself. 11 once. And then that means multiplication. If you don't remember, once you get past 5th or 6th grade, you stop using x because that looks like a variable. So if I write, this is going to take a while. I don't have a touchscreen computer, unfortunately, and it's not super easy to do this with the mouse. So 11, I should have typed it. That would have been faster. 11, what's that? 1, 2, 3, 4, 5, 6. Here, let's do it this way. Oh, that's 7, 8, 9, 10, and then 11 times. That's what an exponent tells you. It tells you to multiply the base times itself, however many times the exponent is. So that's, is that 8? Did I do it too many? 1, 2, 3, 4, 5, 6, 7, 8. I did do it too many. I was thinking 11 times because that was the base. So we only needed 8 of them. So let's get rid of 1, 2, 3, 4, 5, 6, 7, 8. So luckily I changed this new program and I can do that. So I think that should be good. So 1, 2, 3, 4, 5, 6, 7, 8. That's what it means. 11 times itself 8 times. It's still a fraction. This line makes it a fraction. That doesn't go away. So we need to make that line. And then the bottom would just be 11 times itself 4 times. Did not want to do that. Oh, how am I going to do this? I'm going to have to actually write it out. I can't do my shortcut on it. So 1, 1, 1, 1. Oh boy. Not the easiest of tools to do this with. I really wish I had a touch screen. So the bottom, the denominator, is 11 to the 4th, which means it's 11 times itself 4 times. Now, here's the next step. And this is in one of the example problems. So this is example 2. You can just, if you want to go to the online book, which I'll show you later, it's in there. And they do this exact same thing in the book. if we are doing only multiplication and division in a problem, there's no addition, no subtraction, we can say, well, this is really just 11 divided by 11, and then 11 divided by 11, and then 11 divided by 11, and then 11 divided by 11. We can just basically, which all of those would equal 1. 11 divided by itself is 1. So we can just get rid of every 11 that is on the top and bottom. So there's one match. We got to match them up, basically. So there's the last match right there. Now I don't have any more on the bottom. So I am left with 3 11s on top. So there's, I'm sorry, 4 11s on top. So there's 4 left over. Now they can rewrite that back into exponential form. 11 times 11 times 11 times 11 means the base is 11 and the exponent is 4. That's pretty much the definition of an exponent. So that is the final answer, which is the same thing we got when we did it using the shortcut rule. We got 11 to the 4th. And you're probably thinking, well, why in the world wouldn't they just do the shortcut? That is a lot faster. Well, the problem is they'd have to memorize all those shortcuts, all those laws, all the laws of exponents. If they understand how it works, that will work for pretty much every problem without trying to memorize everything. And, memorization may last through tomorrow. It may not, but having it last all the way through the end of year state exam, that's definitely going to be more tricky. But if they understand this, it'll work for all the problems. This is another problem. Again, I'll just tell you the final answer. You can go back and watch the video to go back how to do it if you need to. It would just be 8 to the 15th power. And again, there's a couple ways to do it. I don't care how they do it on the test. They will have to show their work, but that would be the final answer. This problem is like example 1 in the book, page 46. This exponent means, and this is the way the book shows it if you look at example 1, it means 5 to the 12th times itself, just like any exponent. The base now, though, is just a fraction. So that is the base, 5/12. I'm going to do the shortcut on this one because if I did it earlier, it would have worked. But I think this will work. All right. Yep, that did work. Perfect. Oh, I hope it allows me to drag it. Yeah, it did. So there's another one. And I should be able to just paste one more. There we go. Perfect. So this is what this means. The base is now this fraction in parentheses. It means 5 times 5 to the 5/12 times 5/12 times 5/12. Then they have another step, though, that they need to know how to do. Well, sort of 2 steps, but I don't care if they take the shortcut. So again, there will be multiplication in between these. So because this is multiplication and the way you multiply fractions, all we're really doing is multiply 5 times 5 times 5. Taking a shortcut. Hopefully this won't work perfectly, but I'll get it to work. So we take the 5s and we multiply them straight across. It's not letting me scroll over for some reason, but that's fine. We'll fix it. So 5 times 5 times 5 is going to be across the top. And again, there'd be multiplication in between that. So the top would be 5 times 5 times 5. It's still a fraction. If all of these are fractions and we're multiplying them, we're just creating another fraction. So we'd still have a line there. The bottom would just be 12 times 12 times 12. Oh, I think I got to do this if I remember correctly, yeah. So on the bottom of the fraction, we would be multiplying the 12 straight across. Again, this is just how you multiply fractions. We've been over this. They should know this. They really should have known it coming into 7th grade, but sometimes we forget things. So that's how the fraction looks. Now the last step they have to do on the quiz, I'm not sure if I can scroll over anymore. Yeah, that'll be enough room. So the last step for the final answer, oh boy, it's not going to let me do this, is it? Oh wait, actually no, I need to write anyway, so that's fine. Last step is they need to change this back to a base and an exponent for the numerator and the denominator. The numerator is the top part, denominator is bottom part. So 5 up top is the base, because the base is just the number that's repeated. And the exponent is how many times it's repeated. Well, it was repeated 3 times. 1, 2, 3. So it's a 3. And then here, 12 is repeated 3 times, so the base is the 12. And the exponent, I'm going to make it as small as I can, is also 3. So this is the way the final answer will look on the quiz. They're not just plugging it in. This is what they keep just plugging it into a calculator and getting like one number is the answer. Or maybe one really like 125 over, this would be a big number, 12 to the 3rd power. That is not what they should be doing. Now, if we look at the rules again, here's that rule right there. If they memorize it, all you have to do, this is 2 different bases. So just like in our problem, it was a 5 and a 12. So this is like the 5, this is like the 12. This is the exponent that was a 3. It tells you, well, all you really do is you just rewrite it as a fraction. And you just take the exponent and you apply it to both of the 2 different numbers, the numerator and the base. This is exactly what we got. We got 5 to the 3rd over 12 to the 3rd. So again, if they want to memorize the rules, that's fine. I'd prefer them understanding it. But if they think they can memorize it and have it stick, I'm fine with that. Really quickly, there's one more rule. So anything to the 0 power is 1. Any number raised to the 1st power, so 1,000,000 to the 1st power, is just that same number. So 1,000,000 to the 1st power is 1,000,000. 7 to the 1st power is 7. Negative 82 to the 1st power is negative 82. It just, the 1 doesn't tell us any math that we need to do. So it's just the same number. All right. That's most of what they need. I'm not going to do, I will tell you the answer really quickly. So this is the same as the problem up above. The shortcut version is you just take this exponent and it's 3 to the 2nd power over 8 to the 2nd power. So that would be the answer to that one. Again, I'd rather them understand this way because I think that will last longer than just memorizing, but we do what we got to do tomorrow. This problem, it says write 2 equivalent expressions, one with exponents and one without exponents. I just want them to be able to do the same thing they did up here. So if they did this problem and if they do this problem, they can do this one the same way, or they don't have to try it if they don't want to, as long as they understand how to get to this answer and write it this exact same way. All right, so I think, is there another? Yeah. So these are the word problems. These are a little trickier. A lot of kids didn't even get to the word problems. I'm just going to give you the answer and explain it. I'm not going to go through it just because it'll save time and it's hard to, like I said, draw on a touch pad instead of just on the screen. The answer to that one was 3. I just did it one time. I'm pretty sure that I did it correctly, but if for some reason, I'll tell you how to do it. The mean, which is what you're looking for, so the mean is just the average of all the different point spreads that they had. The key is, though, that some of the kids messed up. Well, first of all, some of the kids didn't know how to calculate it. You add up all of the different numbers, however many numbers you get for whatever you're averaging. And once you've added them all up, you divide it by how many numbers you had to start. So in this case, we have 5 games. One game here, the 7, 2, 3, 4, and 5. A lot of kids, though, just added all those numbers up, which is not the way you're supposed to do it. If they won the game, this is a positive 7. If they lost, like right here, that is a negative 2. So the games they lost, those numbers should be negative. If they won, those should be positive. If you add all that up and divide by 5, you should get 3. I have not done these two yet, so I'll do them with you in a minute. I showed them how to do this. We said this word problem here, you basically just take, I don't have a calculator in here, but I'll get my phone calculator going. We did a brownie example in class. They should know the brownie example. I don't know that every class actually got to it today. Some classes were a little more of a struggle. I'll just tell you though, if you want to know the price, I'll give you an example. If you bought 7 tickets and the total was, for all the tickets was, we'll go with $56. So if you bought 7 tickets, oh, I didn't mean to be on that. Still, if you bought 7 tickets, where's a pen I can use? That's not the right one, but that's fine. 7 tickets. Oh, hopefully that doesn't disappear. Oh, that's fine. 7 tickets, and they were $15. I'm sorry, $56 total. I don't really know if this is going to work on this one. See what it does with that. Yeah, perfect. So this would mean if we want to know how much per ticket, so per one ticket, we would just take the 56 and divide it by the number of tickets, and that'll tell us how much one ticket is. So we talked about unit rate in class. It's not really the lesson we're on, but since we talked about it, they can use that. That's how much one ticket would be. It's the same concept here. If they want to know how much it changed every week, well, that's per 1 week. So we could take the total inches and divide it by the number of weeks. And that would tell us, oh, I didn't mean that. That would tell us how much it changed in 1 week. We went over other ways to solve it also. That's probably the way that they're going to understand the best. And there is a question on the test where I believe they have to do something similar to that. So there's nothing exactly like this, but, and again, I think all of you will probably understand how to do it. This is in their book also, but here it is on the worksheet. If the temperature starts at 180.3 degrees, there's a bunch of ways they can do it. I showed them several ways. They could literally just say, okay, well, if I want to know what the temperature is after 20 minutes, they could just subtract 2.5 from their starting number. They could just subtract 2.5 and keep doing that 20 times to represent the 20 minutes. So they could just keep subtracting 2.5. The more correct, or certainly the faster way, well, if it's dropping 2.5 per minute, so every minute, then I could say, okay, well, that means in 20 minutes, I would just multiply 20 times negative 2.5, and then you would subtract that number from the 180.3. So I think the answer came out to be, what is that, 50, so yeah, 130.3 was the answer there. So you can see if they get that. I don't know what the answer was on number 3. I didn't do it, but like I said, if you just take the inches divided by the number of weeks, even if it's a fraction, doesn't matter, it's the same math, that will give you how much it dropped per week. So it should be less than 1 inch. It should be a decimal or a fraction less than 1 inch. I wouldn't worry about B. If you want to do that with them, you can, but there's nothing on the quiz like that. There's nothing on the quiz like that, so I'm not going to worry about it right now. And I think that's really it. Now, there might be other stuff that wasn't on these 2 worksheets. We had other lessons. So I didn't try to give them a gigantic packet. We've got other math problems that they can do. I'll show you those in a minute. But that was the worksheet and some of the... Oh, shoot, I didn't do these. Shoot. Let me do those. So some of the kids didn't. They really are struggling to just put stuff into a calculator, and it's not always as easy as you might think. But so let's do this one. Oh, I will tell you. Here's one thing that they were not understanding. So please tell them this. Let's zoom in on this actually. These bars. So I'll kind of like not highlight, but like. Yeah, I could highlight. Let's do that. So these bars. So this bar right here and this bar right here. Those are absolute value symbols. That means after you do the math inside them, no matter what the answer is, positive or negative, it becomes positive. And we went over the true definition. The true definition is it is the distance from 0 on a number line. So a negative number is the same distance from 0 as its positive version. -2 is the same distance away from 0 as +2. So that's why it becomes positive. But if they just need to, if they're struggling, if you just make sure they memorize that if they see these symbols, that changes a negative to a positive. And if it's already positive, it stays positive. So with that in mind, first of all, you do the math in here. -1.2 subtract 4. Where's my pen? I don't have the correct pen, but I don't like that one pen, but here, let me see if I can. Oh, that didn't work. All right, it looks like I'm going to be working with maybe less crayon's not going to work great either. Dadgummit, where's the other pen tool? Oh, hold on. Tool, there we go. Pen, there we go. All right, so now, inside these brackets, that is -5.2. -1.2 subtract 4 is -5.2, but these brackets change that to +5.2. So they will have to show, actually, you know what? I don't think I am making them show the work if I remember correctly. So that takes care of all of this. So we just took care of all of that. Now it says subtract. And again, this is in parentheses. So they're going to do this first. So they're going to say 5.2 subtract 4.75. So that'll give them 0.45. So I'll come back to that in a second. So once they've done that, then we could really add in the rest of the problem. So division symbol. So divided by 1.5. And then plus. And there is some order of operation stuff they're supposed to know, but they get to use a calculator on the exam. So I've been letting them use the calculator, and really the calculator will take care of it if they just put it in correctly. So now we need to solve this first. This is in the parentheses. We already did it. It was 0.45. Now division would come next in this problem, which is also the same order it would be in, just going left to right. PEMDAS is the order of operations. If you remember that, please excuse my dear Aunt Sally. So 0.45 divided by 1.5 would be their next thing. Again, if you have a calculator, if you just put it into the calculator that I told you guys about, it'll be fine. Negative 3 squared is plus 9. So I'm going to kind of just do that now. Again, if you put it in the calculator, it'll handle it. You can put the negative 3 in parentheses. You may have to put the negative 3 in parentheses on some calculators. I don't think the one in class requires it, but if you don't get positive 9 and you get negative 9, it's because your calculator is actually doing it more correctly than most calculators. So here's what we get down to. So now if we just do that, divided by 1.5, and then plus 9, we get 9.3. So again, I believe that should be correct. I don't have an answer key for this particular book where I got this from. I will also tell you though, if you just plug, like go to use your phone, go to, look up math app for solving problems or something like that, you'll find one and you can literally just take a picture of this and it'll solve it for you to check the answers. So, I'm pretty sure we did that correctly. So I'm not going to go back through this one other than maybe to mention, if I can scroll over, again, inside of this, initially you get a negative value. So you get a negative value in here, 3.2, subtract that would be, what, negative 3.3. But because we have these brackets, just like up here, we had those brackets, it changes that negative. So all of this. I did choose that. Wait, when did that happen? I don't know. All of that becomes positive. So instead of negative 3.3, it's positive 3.3. So that's about the trickiest part. But like I said, if you plug it all into the calculator, the rest of it the calculator can handle. You can't do this part in the calculator. There's no absolute value symbols on the calculator. But you could use parentheses, obviously division, addition. There's a squared button, or just remember this means 4 times 4, so you could do that part first and get 16. Put it into a math app, and it'll give you the answer. I guess I can do it really quickly. Let me just do it. So what do we have? 5 negative, where's my negative sign on this? Oh, there we go. Negative 5.5 divided by that, and then close parentheses, and then plus, and then parentheses again. I don't care if they convert things like this to a decimal, so that'd be 0.25, 2.5. I don't care, so that's not an issue on the test if they know how to do that. They actually should know how to do that. That was one of the lessons we did. And then times 16, and then subtract. And hopefully my calculator does this in the correct order, not just left to right. So I got negative 46.1. I'm using my phone. I'm hoping my phone does the correct order of the operations. But like I said, put it in a math app. Just Google math apps. You can do it on a computer. You can do it on a phone. Photo math is an old one they used to use, I know. But now you can pretty much use Chat GPT, Copilot. I think Apple has its own maybe kind of built-in Gemini. I don't know if Gemini is Apple or not, but Siri might be able to do it. So just plug it in and just make sure these are right when you're working with them. But they need to, the important part is they need to know how to put this into a calculator and get the correct answer. So once you know the correct answer, just have them practice till they get that over and over and over again. Because sometimes they get it once and they can't do it again. All right, so that's all I'm going to do. It's already a way longer video than I meant it to be. I'll be on my computer tonight. If there you have questions on talking points, I might do a little more work on it, just confirm those numbers up there. So I might send another message out late, or just wait on talking points to see if people have questions. Is this recording? Please tell me. How do I stop the recording? So